Hello everyone, I hope you all are doing well. So I am back with a new session on science and technology, and I am going to discuss a very important relevant topics from UPSC prelims point of view, and not only prelims exam but also for main examination. So today we will be discussing about advanced computing. We will discuss about latest development in the field of advanced computing. And we are going to connect with current aspect, with the basic concepts and applications, with whatever important facts are there in three important domains. The very first one, which is making a lot of headlines, that is a quantum computing. Quantum computing and quantum applications. Even it can be done for communication purpose. Now already UPSC has asked a question in the prelims exam that was direct question in terms of quantum bits of information, qubit and quantum computing. But you could expect more questions about quantum computing in coming years exams. So one area we will be discussing now, that is quantum computation. Its potential for application and everything there. Second area which we will go into, another very important one which you all know, supercomputing. Supercomputers and supercomputing. And we'll see the development of the fastest supercomputers in India. So we'll touch upon number of important areas from supercomputers point of view. Third very important area which I am going to cover in this session is about a very emerging area which is connected with the cloud computing, that is called edge computing. Edge computing. So these three areas, quantum computing, supercomputing and edge computing. Right, these are becomes very relevant for both prelims and mains exam for questions there, and we'll go through it one by one. Let's begin first with quantum computation and quantum computing. So quantum computing, lot of development is taking place worldwide in this area. We'll see the basics here, because when the question will be asked in the exam, it will connect with the basic with the application. जब भी क्वेश्चन इसमें पूछा जाएगा तो उसमें आपको साइंस एंड टेक्नोलॉजी पॉइंट ऑफ व्यू आपको बेसिक चीज़ें पता होनी चाहिए, प्लस उसके जो भी एप्लीकेशंस हैं, है ना, जो कि करंट से जुड़ा हुआ वो मालूम होना चाहिए. तो मैं भी इसके बारे में चर्चा करूंगा. बट बिफोर आई गो इन टू दैट, लेट अस नाउ जस्ट टेल यू व्हाई इट वाज इन द न्यूज़. Two important headlines. One, that is a Google company. Google company has achieved. Google has a division called as Sycamore. The parent company Google has a division, Sycamore. And this Sycamore, scientists of this division, that have been successful to demonstrate what is called as a quantum supremacy. That means Google company has built a computer, built a device with the processor, quantum processor, which can carry out trillions of calculation in just few seconds, and that again using very few number of qubits, quantum bits of information. Another headline which has made, that is about China, our neighbor China. Scientists there, Chinese scientists, they have done two very important things. One is that same thing, quantum supremacy. What do you mean quantum supremacy? Which are traditional computers, even the fastest supercomputers, will take months and years to carry out computation and calculation that a quantum machine, a quantum computer can solve in few minutes by using very less number of steps, by simply using qubits. This is called quantum supremacy. Now in what China here, two development. One is that China has developed a satellite, Quest, quantum enabled experiment in space technology, space science, which China developed a satellite here called Mickey's satellite. This Mickey's satellite is named after 5th century BC Chinese philosopher and scientist Mickey's. Now this satellite was built and launched in the outer space, and then it carried quantum communication by using photon light. Quantum communication was demonstrated. That is going to be the future. Today we use microwave, radio wave for communication purpose. Future will be based on quantum. Another thing what Chinese did, there is a quantum supremacy. Just like Google company, even Chinese scientists have also been able to attain quantum supremacy. That has been demonstrated at lab level. Since quantum race has already begun all over the world, India cannot be behind. भारत में भी क्वांटम के फील्ड में R&D रिसर्च के लिए भारत सरकार की मंत्रालय DST, उसके जो विभाग है डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी के द्वारा फंडिंग दी गई है. शुरुआत में 80 करोड़ रुपीस दिया गया है कि भारत में भी क्वेस्ट नामक प्रोग्राम है, क्वांटम इनेबल्ड साइंस एंड टेक्नोलॉजी, एंड वी ऑल्सो वांट टू डेवलप क्वांटम सिस्टम्स which we can use for our national application. So that's what I say, a lot of things are coming up. Future market, commercial domain will be through quantum. And this could be asked in the exam. UPSC can ask questions in the exam. Let's take you to the part of here. If you look at this one, this image, this is a Google company, Sycamore, has developed this chip processor. You know, computer work with processors. So this processor, what you see here, this is a processor which carry out quantum computation with quantum bits of information. And what you see here, this one, there is a quantum computer which work on this processor. Right? This was in the headline there. So what you find here, this Sycamore processor mounted in the cryosat there, done there. So they did the algorithm and they really did all the study there. They did all the part of the see here. Now what is said here? This diagram, if you look at, which a normal computer will take 10,000 years to do the calculation, that quantum computer has done just in the 70 cycles, or you can say number of qubits which was used was just this much of qubits, and within minutes the same complex mathematical problem was solved. This is what this graph depicts, right? And you can see here what is mentioned here, equivalent time assuming the 1 million CPU quantum supremacy, that they have done that. Sycamore processor, 54 qubit processor. That name of the processor, what you see in the, have seen the image, it's called Sycamore. It worked with 54 quantum bits. 54 qubits are there, right? Which is part of it work on this. So testing quantum physics in the lab level. Tomorrow in future, we'll have quantum computers which will use it, and they'll work with such kind of processors, right? Another thing what I said here, another thing which I've said here, that is China. This article came there. China launched its first quantum communications satellite. Quantum communication using quantum cryptography. Cryptography means encoding of data using the qubits. Nobody can hack, right? Cyber proof. Nobody can hack such kind of quantum communication gateway. This is what China tried to demonstrate using a satellite, Mickey's satellite or quantum enabled experiment in space technology. This is what they have done here. So that's what has been now in the news there. So what I'll do here, these I've given a context, a backdrop. Let's understand some key points about quantum there, right? So if you look at the key points here, quantum computer or quantum computing does not work like classical computing. Normal computer what we use in our day-to-day life, including supercomputers, they use the processors, CPU and the processors. They work with the classical bits of information, zeros and ones, right? Such kind of electronic system there. On the other hand, a quantum system, quantum machine, quantum computer, quantum device use quantum bits of information. So here, the first thing is that the information which is encoded, that is in terms of quantum bits. Now what is this quantum bits? Quantum bits are based on principles of quantum mechanics. It follows laws of quantum mechanics like superposition, entanglement, interference, tunneling. Is based on that this states, right? The bits, the states, quantum bits, states are generated where the data can be encoded and processed. ठीक है, तो ये क्वांटम मैकेनिकल के नियमों पर कार्य करता है. तो ये जो क्वांटम बिट्स जो बोलते हैं ये बिल्कुल अलग है. क्या हो सकता है क्वांटम बिट्स? क्वांटम बिट्स जो है ये एक तरह का आयन हो सकता है. फॉर एग्जाम्पल कैटायन, एनायन, sodium ion, potassium ion, any such atomic ions could be there that can behave as a quantum bit. What could be quantum bit? Quantum bit could be an atom. Quantum bit could be an electron. Even the electron can also behave. But very, very important, significant, photon, light. You know, light has got two dual characteristics, particle form and wave form. The particle form of the light, electromagnetic wave, light, photon, that could act as a qubit. Many of the development which is taking place, that is by using the light as a mode of developing quantum bits. Even you know that Nobel Prize has been given for this entanglement, right, which has a lot of applications in future. So now if we see here, it works with quantum bits. Any of such atom, molecule, ion, electron or even photon can behave as quantum bit, right? Now what is second thing here? The laws of quantum mechanics or principles of quantum mechanics which these qubits follow, right? Which the qubits follow. The first thing which it follows, that is called principle of superposition. Principle of superposition. What do you mean by principle of superposition? That quantum bit can superimpose with each other. Like normal bit, you know, 0 and 1, clockwise, anti-clockwise, up and down, right? Quantum bit can be 0 plus 1 at the same time. Quantum mechanics work with probability. That means where the probability is there, कि how many times a particular electron can be 0 or 1. When you use a normal classical one, you are taking absolute 0 or absolute 1, no intermediate part. But here when you take about quantum bit, you are talking about probability. So it can be not only complete 0, complete 1, but could also 0 plus 1. That is called superposition, right? So like when you say here superposition, it could be 0, it can be 1, it can even be 0 plus 1. The states can superimpose. It's a very simple idea. If you take a coin, right, head and tail, and you flip up in the air. So what will happen? As you flip up the coin in the air, the coin will rotate. So when the coin is in the air rotating, you cannot say whether it is a head or tail. Both are there. Both are there because the coin is spinning, right? There is a possibility of that. And as the coin comes on the hand, then we are able to see whether it is a head or tail. Such is the nature of photon light. That means either it could be a spin up, or it can be spin down, or it could be at the same time spin up and spin down. This is called the principle of superposition. Another very important law followed by qubits is called entanglement. This is called principle of entanglement. Principle of entanglement. Entanglement. Now what is entanglement? Pairing. Where qubits are paired. They are combined with each other. If one will change, the other will also change. So that is a kind of encoding, encryption, where quantum bits of information, qubits of information, they are paired to each other. They are connected to each other. If one will change, the other will also change. That is called entanglement. So here, that means a pairing of states of qubits. Suppose that you have two qubits and they are entangled. If one will change, other will also change. So imagine a string of qubits which are entangled to each other. See, if any of the qubit change its position, rest of all will change. And now this finds very important application in cryptography, encoding of data. That means nobody can crack, nobody can hack. If you make change in that information, the entire kind of information set will become invalid. That becomes the core of encryption technology. Even we can use in communication what China did by sending a laser beam of light that went to the satellite and then went back to other one. Any change at this level can be detected by second position. Any change at this one level will be detected by the first one. That is called as a entanglement, right? So that's what China has done there. So there's even the tunneling. Tunneling is what? That means an electron can send and receive data over a long distance. Imagine we have optical fiber optics, and their optical fiber use light that is made of photons. The information can be passed to a long distance. Like that could be happen through tunneling. Again, that is a unique behavior which doesn't happen with the normal computers. It only happens with the quantum system there, right? So these two things. Then third comes here. That means here what I mentioned, that quantum computer can demonstrate supremacy. What is supremacy here? Supremacy here means only few qubits can process data which classical computers require thousands of bits to solve. What I've written here, what is supremacy? Only few qubits can process data, same type of data, which classical computers require thousands of bits to solve. And you can solve very fast, very less span of time. It can solve the complex and complex problem. That's what it comes into that. Another thing, another very important thing is that this kind of quantum computation, what comes here, that is a quantum cryptography. Quantum cryptography. Now, what do you mean by quantum cryptography here? Quantum cryptography means that qubits can be encrypted by using the principle of entanglement, pairing together, encoded. Let's say key, password and key. Normally, classical traditional encryption technology work with public key and private key. Public key can be given others to open and see the document. Private key is used for encoding, that is the individual know that. Here what happens in this kind of a system there, that the system generates random kind of a code. Qubits can generate random type of kind of thing, which will always be different from the previous one. So it helps in proper kind of a security gateway. In this context, there is a something called here quantum key distribution, QKD. Quantum key distribution, and that protects from hacking, cyber fraud and cyber security, and in terms of preventing any kind of hacking and all. That is where the cryptography comes. That's another important application of quantum system, not only in terms of computers but also from communication point of view. Right? This is what I have mentioned here, that you have to be aware of it. And this photon, right? Photons can act as qubits of information. See, when the question will come there, you have to know the basic thing. You have to be aware of the basic thing, right? At the same time, application part. You have to also be aware of the application part. This is what I am trying to demonstrate and show you right now by writing the points there. The basic concept there, right? Context I have given about Google company, Sycamore, processor and China and all this one, but the point is here which you have to know that. So let us now see this quest kind of thing there, which I have just mentioned here. So what China did was this Mickey satellite. The QS experiment, quantum experiment at space level there. That is here. What China did was that it used this satellite and the two parts of China, which were separated by 500 kilometers, more than 500 kilometers. So they used this point number A and point number 2, this is point number B. So the data was sent from point A to the satellite. This is satellite. It was sent to the satellite, the laser beam of light, that means photon, encrypted, entangled, and the same data was relayed back to B. Whatever encoded data went to the S and the same went back to the B. Whatever B sent the data to S, it was sent to the A. It became encoded. So it used the here encryption of data. using quantum keys, right? And this quantum keys, this work on what I mentioned there, they use principle of entanglement. If anything change, any portion of it, the entire thing will change. That means A and S were entangled, S and B was entangled. Any change in A to S, S and B will change. Any change S to B, A to S will change. That was made here, right? So in one way it demonstrated there, and they used as a cyber secured. It was used for cyber secured quantum communication, right? Quantum communication using satellite. And here radio wave or microwave was not used. Simply they used with the communication qubits in form of photons. The light in form of photons. They use laser beam of light, right? That is what China did that. It is there in the news for the last 4-5 years, but UPSC so far has not asked a question. This could be a question in the coming exam. That's what I am discussing right now. So they try to demonstrate using this kind of technology there. So China was able to show, so cannot be hacked, right? It cannot be hacked. Cyber-proof system there, right? So if you understand the thing, if you know the things, then you don't have to worry about. There won't be any kind of a problem in terms of worrying about the things here, right? Sycamore and Google processing, I have already mentioned that. Now let's look at potential application of quantum systems, right, in future. So if we take here, when the question will be there, will be basic concept and then application part. So I'll now come to the application part, right? So we take here application part, same as what we use supercomputers, present time, same way we can also use quantum computers in future. So here, first benefit is what? Less qubit. Second benefit is what? Less time, right? So application, if you look at, so let's the first one in terms of defense and security. So here, use of quantum key distribution QKD technology to encrypt data. It's very important to encrypt data, whether missile or rocket or naval defense or whatever may be that will be encrypted through this, right? That is what comes here. Then next what comes here, that is the solving complex mathematical problems faster than the normal classical computer. That could be done there. Complex mathematical problems that could be solved, right? Then again here, pharmaceutical industry, drug industry or pharmaceutical industry, again to secure drug discovery and drug development Even sometimes vaccine program there. All the data can be analyzed, processed very fast. It can give us the insight into the data. Plus, it will also help in development of that new drug molecule. At the same time, information about that making of drug molecule will remain secured. Right? Even we can use in here in terms of what is called here communication. Like here, communication system, which cannot be hacked. Foolproof, cyber secure. Communication. So it will not use radio wave or something, but that will use by quantum bits of information there. Right? So whatever we do with the supercomputers and all, same task can be done but with less qubits and the faster. So we can have number of applications here. Right? Let me add furthermore. Now look at here. Can quantum cryptography be unhackable? If you see here, what is mentioned here? Quantum cryptography can be hacked. See, there is no something which have 100% everything there. If quantum brings advantage, securing the information, there will be other expert who can also find out the way by which it can crack the code. Now look at what is said here. The security benefit quantum technology arise from being immediately be able to see when someone is tampering with communication. Immediately anybody try to tamper or hack, the system will alert. It will send the warning. There it has a benefit, right? When someone is tampering there, this is due to quantum property of decoherence. When observed for measured, a quantum particle loses its quantum state of superposition and become a regular particle. So system will tell you that there is something wrong going into the system there, right? Therefore, any third party interference would change the message. So one can detect that one, right? So even the eavesdropping, somebody gets into your system and try to get the information. So this could be even one way to get you understand that one here, right? So here that's what given here. Quantum communication faster than the speed of light. See, nothing can be faster than the speed of light. Speed of light 3 into 10 to the power 8 meter per second is the fastest. That is what given by Albert Einstein, theory of relativity. Even quantum bits can do calculation and solve problem, but it cannot solve very fast and even the faster than the speed of light. That is a myth, right? It can solve fast, but not faster than the speed of light, right? That is where the impossibility comes here. Then again here, is this Chinese satellite at the forefront of quantum communication? The answer is both yes and no. One is that it is done at the lab level, but no, why? Because other countries like US and Europe, Australia and all, they are also working towards it, and they can develop more better kind of communication mode using quantum bits than what China has done, right? This is what you find here. Is the US falling behind in quantum information science? That is wrong. I have told that the private company Google has already demonstrated that. American labs are also doing research in quantum part of it, right? That is again the part of there. This is what quantum key distribution. See here. Now what comes here? This is one very important. What is quantum key distribution? Quantum key distribution, QKD, right? QKD. What is QKD here? Involves the exchange of keys between two users. Let's say there is one user Ram, another user is Rahim, Ram and Rahim, and Ram and Rahim, right, send receive the data. Communication system is there. As we do the normal kind of communication, either phone call or sending messages through mobile phone or email, we exchange information there, whatever mode may be. Sometimes video call, right, where face-to-face talk is there. All these are communication mode. So here what happens? Exchange of keys are there. That means the key is then used to encrypt and decrypt message. Then RAM will encode the message, the data, using a quantum key. What is quantum key? That is the password. And the quantum key is based on qubit. And this message will only go to the designated receiver. That is here Rahim. So Rahim will be able to decode. Rahim will decode message or data again using the quantum key, which will be very, very unique. Right? Will be very unique. So here it uses quantum key to encrypt and decrypt messages. This is technically not quantum cryptography, but it was exchange of keys and not transmission of a message. RAM will send a key to Rahim, and Rahim will use that key to open the message and read the message. That's where the quantum key distribution comes. Right? This is what I have explained here. This is all making headlines there. That's what I am trying to make you understand here. Right? Now I will move on what India is doing in this matter. So India has also come out with a program called QUEST, Quantum Enabled Science and Technology. We want to also do R&D in quantum technology. We want to develop quantum technology for market use, agriculture, space, defense, biotechnology, every area. And then we also want to make it the cyber secure system there. Right? So if you take from Indian perspective, we are into a process where we want to take the lead in this area. And in this one, what we have tried to do is that we have developed this, so this Chinese I have already mentioned that this quantum experimental space science that we have seen that this is the document. We cannot remain behind. So here, Department of Science and Technology under Ministry of Science and Technology has already started with a program called Interdisciplinary Cyber Physical System, ICPS, right? A system that is where the Quantum Information Science and Technology, QUEST, mission mode program there. So researchers all over the country are participating in this particular program. They are being funded by the central government, and the researchers are developing those kind of advanced kind of computers which will work on quantum devices, systems. They are all working on that. So here the revolution in this one, quantum information science there. Now what is very important in terms of research here? One is the computation, second is mathematics, right? Third is in terms of data analysis, data processing, data analysis, all this comes into that. So here it involves areas of quantum computing, quantum algorithm, quantum teleportation, that's sending a long distance, super dense coding, remote state preparation, quantum cryptography, several quantum communication protocols. So we are slowly developing and building that kind of a system there. And further it says that develop and demonstrate quantum computers, develop and demonstrate quantum communication and cryptography, development of quantum enhanced inspired technology, the technology which will work on quantum technology, then development advanced mathematical quantum techniques, algorithm and theory, quantum information system there. So central government has already launched a national mission. Now this could also be a question in the exam, right? National mission here. So this national mission, that is called as a National Mission on Quantum Technology and Application, PIB, Press Information Bureau. And you know that questions are asked in the exam from that area, है ना? Even वहाँ से भी क्वेश्चन आता है, तो ये जो है यहाँ से क्वेश्चन आ सकता है. अब क्या दिया हुआ है? Now let's look at here. What is given here? Quantum, if you look at quantum technology, is one of the 9 missions of national importance. Prime Minister has a council. Even for science and technology and innovation, PM has a council. Eminent scientists are part of this kind of council. And PM Council on Science, Technology, Innovation has identified 9 different areas of science, technology, innovation which will transform Indian society. So there is this one of the 9 mission यहाँ पर है. PM का Science, Technology, Innovation Advisory Council, PM STASE, ठीक है. Cutting edge technology which will be used there. Quantum computing, see here, which may include quantum computing, quantum communication, quantum materials. Even development of quantum materials which will build such kind of systems. Again, that is being promoted, right? What do you find here? Then, skilled manpower, scientific manpower, researchers, human resource development. All these are being focused now under this national mission, right? Now, if you see further, if you look at this part, quantum technology is based on principles of quantum theory. Whatever I have explained here. Supercomputers today we are using, future being that one. And when you say quantum, we are talking about atoms. Then we are talking about nanoscale. We are going into nanoscience. Quantum mechanics, we are going to a very, very small level. Even the nanotechnology is also linked, will enable quantum technology. Right? So here, this part comes here, which I mentioned the modeling and everything will be part of it. International status, if you look at 2004, US came out with a detailed roadmap to develop or leverage quantum information system there and the technology. They made a lab also there and they are developing there all this one. Germany, Netherlands, Denmark, Sweden, Russia, all these countries have already begun research and development of quantum computers and kind of a system there. India is also getting into that, right? So that's what background is given here. 72 quantum bits, this one says 2018 Google company, right? 22 quantum bit Bristol cone that is developed. Then 56 quantum bit Sycamore processor has been developed by Google company. There is a company called D-Web. They have developed quantum machine, quantum computer, D-Web company. So private companies are also taking a lead in developing quantum computers, right? So here you find here Universal. So there IBM companies are also taking the lead there, right? China has done Mickey's, I mentioned that. Australia has done. So NASA's status is that we are going to develop the ISRO's quantum satellite. Just as what China did, even ISRO, Indian Space Research Organization, is also working to develop and demonstrate with the help of satellite quantum communication. The institute called RRI, Raman Research Institute in Bangalore, they are being part of project under this ISRO there. And this could be a question in the exam. यहाँ जो बताया गया है कि क्वांटम कम्युनिकेशन को डेमोन्स्ट्रेट किया जाएगा, फोटोन, जैसे चाइना ने किया कि लाइट को लेके, फोटोन को लेके वहाँ पर जो है एनक्रिप्ट किया गया है, जो कि कहते हैं एंटेंगलमेंट जो है. यही चीज़ अब चाइना ने जो किया है वो इंडिया का स्पेस रिसर्च ऑर्गेनाइजेशन इसरो करेगा इन कमिंग टाइम. दैट इज द रमन रिसर्च इंस्टीट्यूट इज पार्ट ऑफ इट. DST initiative to develop the technology and all this one research. Then collaboration with academia, right? Different research institute are then focus on industry. Now very, very important, industry 4.0. The new industrial technologies which will empower the industries in 21st century. IoT, AI, robotics, quantum. Again the roadmap has been made. So you can see here, focus on industry 4.0. Again the quantum will play very, very important role in terms of not only making the processes fast but also secured. Again the PIB document is talking about, right, problem to be addressed here, machines and all this one, frontier research in quantum science and technology, information quantum mechanics, papers, research paper to be published, research done, quantum matters and materials, even the nanomaterials, because quantum is based on nanoscience. All those kind of important materials which we require in quantum systems. Again, the research, development of such materials in India. Again, the focus is being given there. So what you find here, this one, quantum computing and all this. Quantum communication we want to develop. There is satellite communication and all this. Quantum cryptography we are giving the importance there. Quantum metrology, that means measurement, precise measurement, accurate measurement, at the same time secured measurement. That will be also done through quantum. Quantum metrology, quantum sensing, sensors, which use quantum mechanic law, whether agriculture sensors, industrial sensor, whatever sensors are there. Again, they will work on this one. In imaging, quantum enhanced imaging, like cameras, spy camera or any kind of cameras, all the images will generate. Again, they will be encrypted or analyzed through quantum. That is being talked about. So, national gap areas where we have lack of resources at undergraduate, graduate level, because quantum is a very advanced science. Not too much properly focused is at the university level. So that could be another very because lack of resource in India. There are challenges area, negative side. Then you can say here this one, increase university level adoption is lacking there. Build technical infrastructure to advance quantum technology, that is required. So this mission program to develop the quantum base in India has been kept for 10 years. Central government is giving fund for it. So even such kind of government program, which is going to change the entire thing in future, become very relevant for UPSC exam. है ना, UPSC एग्जाम में इसके संदर्भ में क्वेश्चन आ सकता है और ये बहुत इंपॉर्टेंट पार्ट है जो हमें याद रखना है कि कहीं भी अगर कोई क्वेश्चन आता है तो उसको किया जा सके, उस पर वर्कआउट कर सके, राइट. So that is what I have mentioned here, and whatever comes in current affairs you read that. This science and technology book, right, from Oakbridge publication, which is available in Amazon, Flipkart, even in the normal market shops can also you find that. Here in this book there is a chapter on advanced computing, ICT, new technology, and all these edge computing, supercomputing, quantum computing, all these things are already given. और मैंने बताया भी था कि इस किताब से बहुत सारे क्वेश्चन पूछे गए हैं एग्जाम्स में, and even there are topics future based technology, future based things which are making headlines, and where UPSC has not asked question can ask in coming exams is given in the book. ये सारा दिया हुआ है ना. इसमें if you go there you will find everything there. You will find my name there. If you do the Google search you will find with the photograph and all these things. The complete name of the book is Science and Technology from Inception to Advancement. I've given all things there. So those of you who are interested to learn more and read about it, prepare for the examination, can go through the book, right? So I hope that you all are able to understand whatever I am teaching in all my science tech sessions, and you are able to connect there. So I am connecting to those areas which are very relevant, where you could get questions in the exam, right? So I thank all of you for doing this program and knowing everything in there, right? So please go through it, read and revise till we meet in the next session with new topics. Whatever doubts you have, you can always send to us, right? We'll meet soon in the new session with a new topic. Thank you everyone. Take care. Bye-bye.